We have talked a bit about the visual programming side of it, but it's good for us to know, okay, what happens from the visual programming towards other types of information modeling software. So let's talk about, for instance, Revit. So if you go to Revit, and this is just a general template, nothing special, you go to the Manage tab there, and then you open up Dynamo. So every Revit, this is like a Revit 2019 that I have here. Every Revit, I believe, after the 2020 would have your Dynamo automatically installed. You go to the Dynamo, essentially you can play around with it. This is, of course, an earlier version there. You basically have your new, and then you have your Dynamo space where you have it there. Now, you can play around with whatever you want to create. So here I wanted to, let's say, create a particular surface, and you have patch, you have area, you have all various different functions that are similar to the functions that you would see in software such as AutoCAD, sorry. You would be able to, of course, create your own functions. We will not be going through to that part, but this here, I wanted to talk to you about the surface lofting essential command, where you can use it if you have multiple different types of lines. How would we be able to basically create a surface that goes through each and every one of these in a relatively smooth manner? So for this, it requires some cross sections, and these are basically your lines. This could be 1, 2, 3, however many. It depends on how it is, and it basically goes forward. The only important part is the basically the order between where the lines and where the points are, so it can actually loft a particular surface there. So in order for us to be able to create lines, we now have to create a bunch of points. So I wanted to actually loft a surface through 3 lines. And for 3 lines, especially if we want to have 3 separate lines, we need to have at least 2 points that are for every line. So because of that, that would give us 6 coordinates that you need to be able to define, so that you can define the start and the finish of a particular line. And this is the 6 points that we provide there. And for each and every one of these coordinates for every point, now we have a slider number that is related to that. So essentially every free slider number would provide us 1 point, and then another free for another point. We have 6, so we would have 18 slider numbers there. That would provide us with what we need to have in order to specify in a more free way what our points and what our lines are going to be. And I'm going to show you why this is interesting to essentially have these slider numbers there, where they are, and how essentially intuitive it is between Dynamo and, let's say, Revit to play around and get this sorted as well. Okay, so we have our basic few here. You see sometimes with Dynamo, there's some glitches, especially these are the earlier versions. But then what we do is, once we have our 18, we start attaching basically the first to the X, Y, and Z of each and every one of these. So we basically do that, and with this, it provides you with the opportunity to be able to define point coordinates. And then with those sliders, then we can play around with that and then change it as much as possible as well. So we have the X, Y, Z for each and every one of these by means of a slider number. And as you can see, because the slider number starts from 1, these basically transition from 0, 0, 0, which is default if you just have a point there, to, you know, step by step 1, 1, 1, 1, because now each and every one of these slider numbers are 1. So now all of them are 1, 1, 1. And then let's play around with these and see how it is. Again, for each of these slider numbers, you can change the increments of how you want those numbers to change in terms of the units that you want it to change from. And we basically play around and have it in different places where we have essentially 3 different lines where the start and the finish are completely provided and understood. So we go ahead and do that here with respect to some geometry. This is completely random that I'm performing it right now just for visualization and just for your demonstration. However, in particular projects, given some boundaries, given some requirements, you can make these a bit more intuitive as much as possible. And then when you have that, and then you can basically play around with it. If you go to the other one, which is essentially your, instead of the command, what it is, for instance, I saw that one of those points are not as good here, which is that point. I'm going to go back and basically play around with it again and make it a bit more, a bit better in that sense. You can click and see which points that is, and basically maybe take it a bit further in the Y direction, and that would give you a bit of a better, let's say, line, so that you can loft this nice neat surface from all of those points. So then we go ahead and of course we can, let's say, even more so play around with it and see how it is. So once we have this, then we have to create a line between these points that we have here. For every 2 points, we create one line. So what that means is now we go to the line command, and there are various different ways of defining lines, right? We have the tangent, we have, you know, by means of different types of systems. One simple way is to have 2 points and then attach those 2 points together. So we have the start point and then essentially the finish point. And then again, the start point and the finish point there. And then once we have that, we then go and create a list. Because we have only one data that goes inside of, let's say, the curve and the surface there. And this is where it becomes important, because if you do define your own functions and you write your own functions, you would be able to know what are the inputs and outputs. If someone else writes it, then you would have to go and see what that particular function requires from you. So you go to the list here, and then you go to create lists. Basically, that's one. And then you add whichever line it is, with whichever order that you want this surface to be lofted around. So the first one is the middle one, and so on and so forth. And then you plug it in there, and it gives you a surface. Now, here at the very end of it, that means that one of those two needs to be shifted, because it's starting to get one of these points to the other one. That's why it's kind of like twisted that way. The only thing that we need to do in order to fix that and loft it properly is to change the start and the end finish of that line over there, which is the last one. So we go ahead and do that. We go ahead and plug this to the start and the other one to the finish. And now we have a nice surface where we can essentially, given these free lines, this surface is a surface that goes between every two and has some smooth properties as well. Now, we can export this surface to an SAT file or various different types of exports. So you can go to the SAT, and once you export that, again, I would like to remind you that the good thing about this is that you have the abilities to create functions. There are various libraries from very, very well-known architects and people that are in this area. So I also highly recommend. And this is where you can actually create some sort of essentially unit. So imagine you have modeled your column or whatever it is. Now you want to export it to another software that requires, let's say, an SAT file or an STL file and these types of things. SAT and STL are essentially triangulation files. Every surface is represented by a set of triangular meshes that provide that. And then here, the two things that particular function required is the geometry and then the file path. So the geometry is given by means of the surface. The file path, you again go to the file path and then you click it. And once you click it, click on the browse, it shows you the window similar to every other browsing, and you can basically say lecture-free Dynamo example. You go through it, and then this is already saved there. And then when you play around with it, it automatically saves it in that file as well. So that is what the interesting part about this is. Now you can play around with it and see how it is. Now, once you actually, now that you played around with it and gave it a nice surface that you're satisfied with, you can now go to your Revit and then see what happens in the Revit side of it, because these two are completely connected together. Traditionally, you needed to now link that SAT file to Revit. Now, because you have that, automatically you essentially have this information. And then once you go to, and this is for your particular level, once you go to the 3D view of this, it might provide you with a better result. And how you get to 3D in Revit is basically you click this cute house icon there. And once you go to the realistic view, it essentially shows you how it is. Now, let's take these side by side and see how it would, if you change something here in Dynamo, how would that impact the one in Revit? And when you see it side by side, now you can go and play around with each and every one of these and see how it changes. Now, this was a very simple example. I would like you guys to kind of go, of course, based on your interest, to go into a bit more detail, how you can actually go and design some of the interesting parts, some interesting geometry, and let's say the geometry that might not be available in Revit, you would be able to in 3D design it there, have those surfaces, maybe fit something there, and then take it from there. You can essentially now at this time, you can fit whatever you want, introduce it as a curtain or however, for your massing or these types of other reasons that you might need it for. So essentially, this is where the communication is, and it's much more intuitive right now, and it's quite easy. Now, this tool has provided the opportunity for us to be able to have these slider numbers and change it directly inside of Revit. And when these are all connected through various means, the good thing is when the first slider numbers are changing, the whole design would change. And when the whole design changes, you have the ability to observe what would happen in that design as well. So this is where the transition goes. Now you have the ability to, let's say, fit something to it, identify a particular item, assign its material properties and these types of aspects, and complete the information modeling process.